Hey there. So today I'm back with an exciting video where we are going to cover the basics of APIs and we are going to learn how we can create our first API with the help of Spring Boot. And we are going to use IntelliJ throughout the entire process. And to make use of our API, we will use POSTMAN. So we will begin by talking about the basics of web and API. And then we are going to cover the basics of Spring Boot. And then ultimately, we will learn how you can make use of Spring Boot to make your APIs. So it will be a simple API that will give us enough hand-holding with Spring Boot. So if you are new to this channel and if you have not subscribed yet, hit the like button and also subscribe. That will motivate me to keep bringing such amazing content for you all. So what are we waiting for? Let's get started.
Hello everybody, let's start talking about APIs. So in today's world, interactivity and connectivity between the software systems are key, and APIs have become a crucial part of many modern software systems and applications. But what exactly is an API? So API stands for Application Programming Interface. Alright, and API is a short form of this word where A stands for application, P stands for programming, and I stands for interface. Now, what does it mean? So, APIs are nothing but a set of rules or protocols, you can say, that allow one software application to interact with another. So, with the help of these rules and protocols, two software applications or two software systems can communicate with each other. So you can think of it like a messenger that delivers your request to the provider that you are asking a service from, and then it delivers the response from the provider back to you in the form of the response. Alright. Now API is not a database or a server, but it is a piece of code that governs the access points to the server. Alright. Now, you can think of APIs like a restaurant menu. So, if you go to any restaurant, a menu provides a list of dishes that you can order, along with the description of each dish and the price. And when you specify what menu items you want, the restaurant kitchen will prepare those items for you. It will do the work, and then it will provide you with some finished dishes that you can consume. Alright? Now, you don't know the process of how the restaurant prepares the food in the kitchen, and you don't really need to know. Similarly, an API lists a bunch of operations or a bunch of URLs, you can say, or in more technical terms, they are called as endpoints. So these are endpoints along with the description of what they do, and you as a developer can use them to build, or you as a developer can use them in your application for whatever purpose you need them for. Now let's talk about why do we need APIs. So the number one reason is to share data. So APIs allow different software applications to interact with each other and share data. And this functionality would have been impossible otherwise without the presence of APIs. The next benefit or the next need for API is to speed up the development. So with the help of APIs, you as a developer can use pre-existing frameworks or pre-existing functions that are already built somewhere else, and you can consume them with the help of APIs. Okay, and you don't have to write that piece of code or that functionality from scratch. So this saves you time, and ultimately it will end up boosting your speed and productivity. Now, APIs also allow you to extend the reach and functionality of a software. So if you are a company, API can allow a company to give their APIs to third-party developers, and third-party developers can consume these APIs and build on top of this. So let me give you some examples of some of the popular APIs that exist. So the number one API would be Google Maps API. This is quite popular. Twitter API. Then we have Facebook's Graph API. And Amazon S3 also has an API. So let us head over to our browser and let's take a look at this. So here in the browser, I am having some tabs open over here, and you can see like this is the API of Google Maps, okay, where you can see. So here you have different functionalities like maps, routes, and places. So you can see like all the SDKs and everything related to maps. You have the routes API. So if you click on this, I'll open this in a new tab, and you can see over here, this is used to plot routes on Google Maps. All right. And you can use this API to build a ride sharing platform or anything like that. So Uber and other ride sharing apps use these APIs in their application. So you can like take a look at the documentation here. Okay. So you'll see everything as to how you can access the endpoints and what are the results that you will get. So you can play around with this. You have Twitter as well. So they also expose their APIs, and this is the page like developer.twitter.com, wherein you can go and take a look at what all they have to offer. So you can take a look at the getting started page, about Twitter APIs, and so on. All right. So this is Twitter, and it helps Twitter to expose the functionality of the Twitter app. And you as a developer can use these APIs and build on top of this. So if you want to build, let's say, an app that displays analytics of Twitter profile, so you can use these APIs and consume them in your application, okay, without having to build everything from scratch. And for Twitter, it enables them to expose their functionality to the outside world, and anyone in the world can come and consume these APIs and extend the functionality of Twitter. Okay, so it helps Twitter as well. So this is about Twitter API, and then we have this Facebook APIs, which you can access on developer.facebook.com. And you can see there are quite a few categories here, like the app, gaming, business messaging, AI, and so on. You have authentication. So if you are planning to implement authentication in your application, you can use Facebook login. Okay. And how do you use Facebook login? So you have different options. So within Facebook login, you can see like iOS, Android, web. So if I go to web, okay, you will see how you can use them and how you can build this functionality. So this is all about API. Now back to our presentation. Let us talk about the different types of APIs. So the number one type is the internal APIs. So internal APIs are APIs that are built for internal teams' purpose. So within an organization, there will be scenarios wherein one team might want to expose the functionality or anything that they have built to some other team or the rest of the organization. And in such scenarios, that particular team can expose whatever they have built with the help of APIs, and the rest of the teams or the other teams in that same company can consume these APIs. All right. For example, a very good example of internal APIs is, let's say you have an infrastructure team that is working on the notification system. Okay. Now notification is common for entire organization. So let's say the organization has a product and it's a ride sharing app, and there are different teams there. Like there is the ride app team, like there is a user app team, partner app team, and so on. Okay. Now, every team would want to send notifications to their customer. So what they can do is they can make use of these APIs that the infrastructure team has built. And these APIs are used to send notifications to the user. So the other teams can consume these APIs and they can skip the functionality of building the notification system. So the system is built once and being used by everyone else within the organization. Now, this kind of API cannot be exposed to the outside world. Like you don't want outsiders to send notifications to your users, right? That would be crazy. Like you just want your internal organization members to send like notifications. Like for example, marketing team might want to send some notification from the marketing dashboard. So it's internal to the organization, and that is what internal APIs are. So these APIs are internal to the organizations and are not supposed to be exposed outside. Then we have external APIs, and these are public APIs. So external APIs meaning they can be used by anyone in the world. And some examples of external APIs are like Twitter APIs, Facebook APIs, Google Maps APIs, and so on. So these are the APIs that can be used by anyone across the world. And then you have something called as partner APIs. So these APIs are built for specific partners. So let's say if you're working at an organization that is building a ride-sharing app, and if you have partnered with someone, and as a result of the partnership, both the companies are doing some sort of integration. Now in this case, both the organizations might want to expose some functionality to each other. And in this case, the APIs that are built are only for this partnership and are to be used by the partners within this deal. Okay, and that is what partner APIs mean. Okay, so partner APIs are built for specific partners for a specific use case. They are just open to that partner itself and not to the rest of the world. All right, so this is about API, and APIs are crucial for modern web development, and they play a key role in software communications and functionalities. Okay, and understanding how APIs work is really important for you as a developer and anyone that is working in the tech industry. So that's about this class, and I shall see you all soon. Thank you. Let us start talking about status codes in APIs. Now, when you communicate between systems with the help of APIs, there has to be an indicator which indicates the result of the request. Now, this can sound like an acknowledgement. So when you communicate with someone, you need some sort of acknowledgement from that person. And this is exactly how it works in the case of software systems. And this acknowledgement in case of APIs is status code. So when APIs communicate, they use status code to indicate the result of the request. Okay, and these status codes are part of the HTTP protocol, and they can tell you whether the specific request that you did to a particular server has been successful or there were some failures or issues along the way. Now, let me give you an example. So let us say you have a cloud server here, as you can see, and you have two clients. So one is the mobile phone, and you have an application that is running on the desktop. This is how a typical application looks like. You have a remote server, and then you access the data on this remote server with the help of a client, which can be right from the mobile app or it can be through the browser. Okay. Now, when you want to interact, you will send a request to this cloud server. Okay. So this request goes to the cloud server and then you expect a response. So you get a response along with the status code. And this code tells you whether it was successful, like the request was successfully processed or it was not. And there are different codes that indicate what happened with your request. Okay. Now here, status codes are important because whenever we make a request to the server, okay, we receive the response, of course. So response we'll get, but who will tell us whether it was successful or it was not? So with the help of status code, and status code is that identifier that helps you understand this. Okay, so status codes are 3-digit numbers that represent the status of the HTTP response. And they help us identify the outcome of the request. And status codes can be classified. So there are 5 categories in which status codes can be broadly classified into. Okay. And the first digit of the status code defines the class of response, while the last 2 digits do not have any role in the categorization. Okay. So for example, you have this one category which starts with 1, and this means informational, and it indicates that the request was received and the process is continuing. Then you have 2XX, so it can be 200, 201, and this indicates that the request was successfully received, understood, and accepted. Then you have 3XX, and this indicates redirection. Okay, now this will tell you that the further action must be taken in order for the request that you have sent to complete. Okay, so if there are redirects, like 301 is the code to redirect, so you will receive a response starting with 3. Then you have status code starting with 4, which indicates client side error. So you as a client are requesting something from the server, and if there is an issue from your end, that is what a status code starting with 4 means. Now, an issue from your end meaning like you can send requests that might have bad syntax or like incorrect parameters, or the request is not formatted properly in the right format. So all these kind of issues are arising from the client's end, and that is when you get the request response with the status code 4xx, and this indicates client error. Then you have 5xx, which indicates server error. So like there will be scenarios wherein the server failed to fulfill an request, like there is an error or there is an exception that has happened or the server crashed or something. This response code will start with 5xx. Okay, now let us take a look at some of the commonly used status codes. Okay, so the number one status code is 200 OK. Okay, and this is like the most commonly used status code, and this is standard response for a successful HTTP request. Then you have 201, and it indicates the resource is created. Okay, so whenever you are sending a request to the server to create something, like for example to create a user or create a product or something like that, then you get 201, which indicates that whatever your request was, it has been created. 204 means no content, and what this indicates is the server has fulfilled the request, but there was no representation or nothing to return. 301 indicates moved permanently. Okay, and whenever you try to hit a URL or an API call which does not exist or it has been moved, then you send the status code as 301. And this tells you that the requested resource has been moved permanently. Then you have 400 bad request, which means the server could not understand the request due to an incorrect syntax. So if you as a client are sending some request to the server and the syntax or the parameters are not right, then you get 400 bad request, which tells you that the request you sent is not valid. Then you have 401 unauthorized. So this indicates that the request that you send does not have authentication credentials or it's not authorized. So there will be scenarios wherein some APIs will be authenticated. Okay, so if you try to access, let's say Twitter APIs, those APIs need to be authenticated because you cannot access users' information without authentication. Now, if you try to access the API without authentication, that is when you get 401 unauthorized. And this tells you to include the authentication information as a client into the request that you are sending to the server. Then you have 403 forbidden. Okay, so this indicates that the server received the request, it understood it, but it refused to authorize it. Okay, so it's something forbidden that you cannot access. Then you have 404 not found. So this means like you're trying to access something that does not exist, and that is when you get 404. So if you're trying to access a URL that does not exist, you get 404 error. Then you have 500 internal server error. So this means that whenever you're sending a request to the server, and there has been an unexpected condition, okay, because of which an error has occurred on the server, and that is when you get 500, okay, which indicates that some issue has occurred on the server. So these are the different commonly used status codes. Okay, now understanding status codes is crucial when you're working with APIs because they help you understand the essential information about how a request is processed, and it also tells you what happened to your request. Okay, so it gives you a clarity as to what is happening behind the scenes. Alright, so that's about status codes, and I shall see you all soon. Thank you. So when talking about APIs, it's also important that you understand the different types of API requests that exist. So what are the types? So the number one type is the GET request. Then we have the POST request, PUT request, and DELETE request. So API request that you are doing to a server can be categorized to any of these four types. Now let us understand each one of them. So we have GET request, and this request is used to retrieve or get something from the server. Now this can be any resource, any data, or any kind of information that you need from a particular server, and server will help you fetch this from the database. And GET requests are only used to read data and not change it. So like the word says, GET. So it is just used to get the information and not to modify anything on the server. And whenever you're using this kind of request, you will get status codes like 200 OK, or if you're trying to access something that does not exist, you will get 404 not found. Okay. So this is GET request. Then we have POST request. Now POST request is used to create a resource on the server. So if you are allowing users to sign up through your mobile application, you will have access to the create user API. And with the help of that API, if the user signs up, you can create a user onto the server, which will in turn get saved in the database. So this way, you are making use of this API to save the user's information and credentials. And you can do this with the help of POST request. So you cannot use GET request in this case. You will get an error. So the request type has to be POST. And when using POST request, some common status codes that you will encounter is 201 created, because when you create anything on the server, that is what server will respond generally. And if you're trying to access something that does not exist, you can get 404 not found, or you can even get bad request status code if you are not calling the API correctly. All right. So this is about POST request. Then we have PUT request, and this type of request is used to update something that already exists on the server. For example, if you are allowing users from your mobile application to update their personal information. So if they have an edit profile page, they will update the information, and once they hit save, you as a mobile developer can call the PUT request, which you have been given access to. And with the help of PUT request, you can save the information and update it against the user. Okay. And keep in mind, PUT request is not used to create anything, not to get anything, but it is used to update something that already exists on the server. And when you're working with PUT request, you will normally get 200 OK if your request was successful. You can get 4 not found, or you can get bad request, which is 400. So this is about PUT request. Then we have delete request, and delete, as the name suggests, it is used to delete resources from the server. For example, if in your mobile application, you have a way for users to delete their account, for example. So this way you can make use of delete request. If the user presses that button, you might want to delete the user account details and everything that user has done in your application. And you can make use of delete request for this particular purpose. And keep in mind, delete is just used for deletion purpose. It is not used for post, put, or updating anything, or getting anything, or creating something on the server. All right. And normally you will get 200 OK if your request is successful. You might get 404 not found if you're trying to query something that does not exist. Okay. Or you might get 400 bad requests if the format is incorrect. So this is about delete requests. So these are the different types of requests that exist and you can make use of in your application. All right. That's about this class. I shall see you all soon. Thank you. Hello everybody. Let's start talking about what is a web framework. So first, let's get into the specifics of why do you need a web framework. So if you look at most of the web applications that exist today, they have a lot of things common in them. For example, all web applications need to serve the web page when a user tries to access a certain URL. All web application needs to have the aspect of security. All web applications need to have databases, authentication, and so on. So there are lots of common elements that exist in the different web applications that exist today. So these are just the standard list of things that I mentioned over here. But the question is, should you build this thing as a developer every time when you build an application right from scratch? So think of this as building a house. So if you build a house, you would need some blueprints and tools, okay? And for web development also, that is how things work. So you need set of tools, like some set of pre-built things that you would be incorporating in your web application, and developers earlier had to build these things right from scratch. Okay, so if you have to build a web application in Java, you have to manage things like security, authentication, and everything, like how a URL is accessed and all these things manually. So this was the case early on. Okay, and this was written manually by the developers every time they create a new web application. There was no boilerplate or a starter template that they could use. And this was very effort taking and is required by almost every website out there. Like, developers cannot say no to this. Okay, so you can compare this with the analogy of building the house. Okay, what if you had a set of tools, a blueprint ready? Okay, because every house needs that. Okay, they would need certain tools, they would need some sort of a blueprint to set up things quickly. And that is where web framework comes into picture. So what if I would tell you that you could have some prefabricated components that you could use, okay, and you could just use these prefabricated components that you could assemble to make a house with fewer errors, a lot more faster. So by prefabricated components, I mean pre-built walls, doors, windows, and so on. Okay. Now, you could assemble these faster. Yes, right? Like if you could get a list of prefabricated components, you could put them all together really, really fast. And you could also reduce the number of errors that you would get during the process. So this would make the entire process a lot more easier, faster, and you could focus on important things rather than doing repetitive things. And of course, this would make you fast. Now, this is what a web framework does. So what is a web framework? So web framework is nothing but a collection of tools and modules that is needed to do standard tasks that are required across every web application. Okay. So web framework consists of some standards. Like for example, every website needs to serve web pages, interact with the database. They also need to interact with the web host. And hence, web framework take away these repetitive tasks and have a standard defined which you as a developer can follow and use that as a starting point. So rather than creating a blank new file when you start creating a web application, okay, you can use something called as web framework, which has some set of things already pre-configured. And this makes you a lot more faster. The benefit of this is you get to focus on important things rather than focusing on or doing a lot of repetitive things. For example, you can focus on business logic rather than setting up things and the boilerplate code. So that is what web framework is, and it makes your life a lot more easier. So you can compare this with the analogy of house building. So if you could have pre-built house, like a pre-built wall, pre-built windows, and so on. Like windows you would need for every house, right? You would need them in different sizes. So what if you could have a set of windows with different sizes and you could just pick the window that you want whenever you're building a particular house. Okay. So if you want a window of 3 feet, like 3 feet wide, you have a list of windows, like you have 3 feet wide, 4 feet wide, 6 feet wide. So you could just pick 3 feet wide window and you could use it in the house. And that makes your life much more simpler rather than building things every time from scratch. So that is what web framework is. So Let's talk about the popular web frameworks that exist in the market today. Now, there are many web frameworks available for different programming languages, and each has its own strengths. Okay, we'll talk about some of the most popular ones. So, the number one is Spring Boot. Okay, so Spring Boot is a Java-based web framework, and it is used to build a lot of enterprise applications out there. Okay, and it allows you to build them really quickly. So it takes away the hassles, a lot of auto configuration, and there are a lot of good features that Spring Boot offers to the developers. Okay, but yeah, Spring Boot is one of them, and it is Java based. Then you have Django, which is a Python based framework. Now Django is also known as batteries included web framework, which means it includes a lot of common functionalities built in. Okay, so if you learn more about Django, or if you read more about Django framework online, you will see this term batteries included being used at a lot of places. Then you have Flask, which is also a Python framework, but it is much more lightweight, flexible, and it is great for small projects or when you need more control over the code. Then you have Express, which is a JavaScript based framework, and it's a part of Mean Stack or Mern Stack. Okay. Now, what I mean by Mern Stack is Mongo, Express, Angular, and Node. Okay, so this is widely used for building APIs using JavaScript. Then you have Ruby on Rails, which is also called as ROR, and it is based on this Ruby programming language. Okay, and it is known for its philosophy of convention over configuration. Okay, and it helps you increase your productivity once you understand its conventions. So that's Ruby on Rails. Now, a lot of these frameworks are being also used by top companies. For example, Instagram and Pinterest use Django internally. Twitter and Airbnb have used Ruby on Rails. LinkedIn uses Express.js for server-side rendering. Netflix uses Spring Boot, and so on. So if you learn and Google a bit more about these frameworks, you will know there are a lot of companies, big tech companies, they are using these frameworks for the day-to-day life. Okay, so that's about web frameworks, and I shall see you all soon. Thank you. Let's start talking about Spring Framework. So Spring Framework is a Java-based framework, and you have Spring Boot, which is based on Spring. Okay, so Spring takes away the hassle of building applications. So there are lots of things and lots of manual things that developers had to do before Spring came in. Of course, a lot of hassles were taken further by Spring Boot, but Spring also was a good enhancement to the traditional way of building application. So with Spring Framework, building enterprise grade applications is really easy. And let us take a look at some of the features which will help us understand what are the benefits and values Spring Framework provides to the developers like us. So the features of Spring Framework. The number one feature is the inversion of control. So Spring manages the lifecycle and configuration of objects. So if you're building an application, you will have a lot of objects that you use. So the lifecycle, the configuration of these objects are managed by Spring. It reduces the dependency and increases the flexibility for developers. Now, when I say Spring Framework manages the lifecycle of objects, these objects within application are known as beans. So the objects that are managed by Spring Framework are known as beans. And inversion of control is a design principle that is commonly used in software development, but it is a very valuable feature of Spring Framework. Okay, so in traditional programming, objects were responsible for creating and managing the dependency, but with inversion of control, the responsibility is inverted. Okay, and here the framework, which is the Spring Framework, takes charge of this. Now, how does Spring do this? So Spring does this with a feature called dependency injection, which allows it to define the dependency of the class externally, and it provides them to the class whenever the class needs it during the runtime. Okay, so let us take a look at one of the example which helps us understand this better. So let's take a look at this particular source code where you have an interface called message service. And what you're doing is you are implementing the message service to this particular class. Okay, and you have this particular method which is defined over here. Now let us say you use message service this way over here in SMS client. Okay, so in SMS client you need this object message service. Okay, and you're creating the object of email service and assigning it to the message service, and message service over here was an interface, as you can see. Okay, so this is source code and you're using it properly in your method over here, send message. All right, now over here what is happening is SMS client class creates its own instance of email service over here within the constructor. The dependency between the SMS client and email service is tightly coupled. Okay, as SMS client explicitly knows about and creates the instance of email service. Okay, now without IOC, so here in this example we are not using this feature of inversion of control. Okay, so without this feature, the responsibility for managing the dependencies lies with the class over here. Okay, so this particular class is taking care of managing the dependency. It is creating the dependency since it has the dependency on this particular object, and it is using it in its source code. Okay, now this makes the code really tightly coupled, and it makes it harder to modify and replace dependencies in future. And there are lots of problems that are associated with this approach. Okay, so with inversion of control, Spring takes care of managing these dependencies which are being managed manually as of now. And what Spring Framework also does is it injects them into the class. By injecting, what I mean is it makes it available during the runtime to the class so that the class can use it. And this allows for a more flexible and a modular version of the code, as the class itself does not need to be concerned with creating and managing all of this. Okay, by all of this I mean dependencies. So Spring Framework simplifies this. Okay, now imagine here you have just one dependency. Let's say if you have hundreds of dependencies, the source code will become a lot more complex, large, and the benefit of inversion of control will become much more evident. So let me give you an example of the same source code with the inversion of control in Spring. So here you have these two methods that we spoke about, and now let us take a look at this version over here. Okay, you can take a look at this version where you have declared this particular object message service. So here in this constructor, SMS client has dependency on message service, but instead of creating the message service instance within the SMS client, we are providing it through the constructor. Okay, and Spring's inversion of control container manages the life cycle of the bean. Now what I mean by bean is, so bean are the objects that are managed by Spring Framework. So what happens is during runtime, when you run this program, Spring Framework automatically injects the appropriate implementation of message service into this constructor, such as email service over here, and it makes it available for SMS client class, which it can use in this particular constructor and ultimately within this particular program. So with the help of this feature and by using the principles of inversion of control and dependency injection, Spring allows for loose coupling between components. It promotes, you can say, modular design. Okay, this design is much more modular, and it also makes maintenance a lot more easier in future when your code base grows. Okay, and it also separates the concerns and facilitates faster development and higher modular scalable applications. Okay, now this is inversion of control, and this is one of the powerful features of Spring Framework. Okay, so I hope you have a clarity over here. Let us jump to the next set of feature. Next is data access. So Spring Framework provides a consistent and a easy way, which is a lot more simplified, to handle data access. So what I mean by data access is accessing data from different data sources. Okay, like you might want to access data from PostgreSQL, MongoDB, MySQL, and so on. So Spring Framework has things like JDBC, Hibernate, JPA, which makes your life a lot more easier when you are building database driven applications, and it enables you to work with databases or data sources in a easy and simple way. So that is about data access. MVC framework. So Springs has web MVC framework that provides a clear separation. So it provides a clear separation between the model code. Now what I mean by model code is the code where your entities are there and also the web form. So code where your entities are stored, basically that is created for the database purposes. And then you have the view which is responsible to interact with the user. Okay. So in model view controller design pattern, you have a model wherein you have all the entities out there. You have a view which handles the UI related logic, and then you have controller which handles everything in between and makes sure that everything works smoothly. So in this MVC model, Springs makes sure that it provides clear separation between all of this. Then you have transaction management. Okay, so it provides a unified way to manage transactions across objects. It also has an aspect of security. So Spring Security is a module that exists in Spring Framework, and it is highly customizable, feature-rich security framework that helps developers like you to secure their application. Okay, so it provides features like authentication. It enables you to protect against common site vulnerabilities, and it enables you to define authorization in your applications. Then testing support. So Spring Framework also has good support for unit testing and integration purposes. So it provides features like Spring Test Context Framework. Okay, it has good integration with frameworks like JUnit, Mockito, and so on. Okay, you can write test cases, do mocking, and so on. Then internalization and localization. So it provides support for both of these, allowing developers to build applications that can easily be adopted to different kinds of languages and locals. Let's talk a bit about history of Spring Framework. So Spring Framework was developed initially by Rod Johnson in 2002. And Johnson's goal was to create a lightweight alternative to Java Enterprise Edition, which is JEE. And he released the first version of Spring Framework in March 2004 with lots of core features. Okay, so the goal here of Rod Johnson was to simplify the development with JEE, which is Java Enterprise Edition, and it wanted to provide a lightweight approach to JEE. And that is what the Spring Framework was. So since 2004, Spring Framework has gone a lot of changes. Okay, it was first released in 2004, and since then it has gone through major developments, and a lot more versions have been released with a lot enhanced features. So that's about Spring Framework, and I shall see you all soon. Thank you. Let's start talking about what is Spring Boot. So Spring Boot by definition is an open source Java-based web framework which is used to create standalone production grade applications which are built on top of Spring and Java. So it's a Spring based web framework, okay, and it runs on Java. And also one thing to note over here that it's open source and freely available. Now, what is the benefit of using Spring Boot? Like, why would you use Spring Boot over Spring? And what is the advantage that Spring Boot gives you? So, here's the difference between Spring and Spring Boot. So, with Spring, there were lots of things that were involved in setting up, configuring, writing boilerplate code, and also deployment of the app. Okay. So of course, when it came to building apps before Spring, like before Spring was invented or created, there was a lot of boilerplate code, and Spring reduced that to a lot more extent. Okay. So a lot of boilerplate code was eliminated with the help of Spring. But with Spring Boot, the boilerplate code was further eliminated. Okay. So with Spring Framework, you had a lot of things available readily, but still there was some configuration to be done. There were a lot of steps that were involved in setting up and also in the deployment of the app. For example, if you're building an application, a web-based application, you're building it on your local machine first, right? Because that is a development environment. Now, to test your application, you need to have a local server running on your system. So with Spring, you had to set up a local server wherein you deploy that app and you configure the app that you're building with that particular server. And you had to do this for every application you build. Of course, a lot of things were automated and pre-configured, but yes, there were some things that were left out. And that is where Spring Boot came in. So Spring Boot offered a set of pre-configured components and defaults, and it eliminated the need for a lot of boilerplate code that was involved in setting up a Spring application. It went a step further. So you can think of this as, so analogy that I can give you over here is of a Maggie. Okay, so if you're building or if you're cooking Maggie, let's say, okay, and how do you cook a Maggie? Like you have a sachet with a pack of noodles and you just put it in hot boiling water, you boil it for 2 minutes and you're done. So that is pre-configuration. Okay, it's pre-configured. So you didn't have to do anything. You just had to get a pot of hot boiling water and you had to tear the packet and empty the noodles into the boiling water, and that is it. You're done. So the packet had a lot inside, so it was pre-configured, okay, to be cooked this way. All right. So it reduced the effort at your end and you could enjoy your meal quickly. Okay, so this is one analogy that I could give you when it comes to Spring Boot. Spring Boot operates in a similar way. So you just get the source code, you create the Spring Boot application, okay, and you can run it with a single click. It's that fast. Okay, it's ready to be built. Okay, so you can think of Spring Boot as Spring Framework plus a lot of pre-built configuration plus embedded server. Okay. So Spring Boot is equal to, you have Spring Framework, pre-built configuration and embedded server. So for running the application, like I said, you need a server, okay, and Spring Boot has that pre-configured, okay, and embedded within it. So when you create a Spring Boot project, you don't have to set up a server where you would be testing your application and running locally. It's all embedded. You have to just create the project, okay, write some source code for your application and run it, and it will run on the embedded server. Okay. Also, there is a lot of pre-configuration that goes, which we will talk about. Okay. So this is Spring Boot. Okay. And it eliminates the need for a lot of boilerplate code, like I mentioned right now. It levels up essentially the development that you are doing with Java and Spring. Okay. So if you're using Spring Boot, you are much more faster. You get to focus a lot on business logic rather than doing these daily tasks like embedded servers, and these are all manual things which can be taken care of. You as a developer can focus on the business logic, which is really, really important. Let's now talk about the components of Spring Boot. So the number one component is Spring Boot starters. So what are these Spring Boot starters? So these are a set of convenient dependencies, okay, that can be included into your application. Okay, like you can say these are ready to use ingredients. Okay, so for example, if you're building a web project or if you're building a REST API, you know you will need to create some REST endpoints. Okay, and for that you have a starter. If you're building a web application, you have a web starter, which signals that you're building a web application and all the configuration that is related to a web project is pre-configured and included. Okay, if you're building a database driven app, you have a starter for that. So whatever is needed for a web application that interacts with the database is pre-configured into that. So you have to just include that and it's done. So this is what Spring Boot starters are. It's a library or a shop, you can say, which has a lot of components ready to be included into your Spring Boot project to accelerate your development. The next step or the next component is auto configuration. Now, Spring Boot auto configuration attempts or it configures automatically your Spring application based on the dependencies that you have added. So if you have added, let's say, a dependency for database. So all the configuration that is needed for database is automatically taken care of. So Spring Boot determines that, hey, this particular application has database related dependencies. So guess what? It's going to use database. So I need to configure things that are needed for database, and it will take care of that. You don't need to do manually. Okay, you just need to set some properties like username, password, or the host where it can find the database and so on, but they are very minimal, and Spring Boot does the heavy lifting over here. So that's auto configuration. So based on like whatever dependencies that you have added in your application, it configures or auto configures things for you. Okay, you don't have to deal with the configuration manually. So this reduces a lot of hassle. Then you have Spring Boot Actuator. Okay, now this is one of the non-functional features. So if you're building a Spring Boot application, you would need a way to monitor that application. You would need to gather some metrics like how many requests are coming, is the application up and running. So all these kind of monitoring things, these won't be the requirements that your client is going to tell you. Nobody is going to tell you these requirements. From the developer standpoint, these are needed for you. Okay. So Spring Boot provides Spring Boot Actuator, which you can add to your project, and it will enable the production ready features like monitoring your application, metrics gathering, tracing your HTTP request, and so on. Okay. So that's Actuator. Then you have Embedded Server. So Spring Boot includes an embedded server like Apache, Tomcat, Jetty, and it allows you to run your application as a executable standalone jar file. Okay, and this eliminates the need of you deploying your application on a separate server and testing it. Okay, so it simplifies the process. Then you have Spring Boot DevTools. So DevTools is a set of development tool that enhance the productivity during application development. So for example, if you make some changes, you might want a automatic application restart or redeployment, like live reload of static resources and so on. You might need some better logging or enhanced logging for faster development. So all of this is provided by Spring Boot DevTools, and you can include it into your project. Let us talk about the advantages of Spring Boot. So number one advantage is it's standalone. Now what I mean by standalone is it can be started using a command java-jar, and it does not need to be deployed on a separate web server. Okay, and it allows you to get quickly started, offering rapid application development. Okay, then it provides you with starter code. Okay, now like we discussed, starter projects enable you to get started quickly. It takes care of configuration and dependencies that are predefined, okay, and that are needed for every web application. It needs less configuration, okay, which means like since the configuration is taken care of by Spring Boot itself, there is very less need or no need to do configurations manually. And because of all this, it enables a company to reduce the cost and the application development time, and it helps them to go to market really, really faster. All right. So these are some of the advantages. And because of these advantages, a lot of developers love Spring Boot. And some of the reasons are it's Java based, which is one of the most popular programming languages out there. And it's fast and easy. Yes, it enables faster development and it's easy to use. Comes with an embedded server. It has various plugins and a lot of boilerplate code and configuration is avoided. All right. So that's Spring Boot for you. Thank you. Let's talk about Spring Boot architecture. So Spring Boot has a layered architecture wherein one layer will communicate with the other layer. And there are a few layers or a few tiers that exist in a typical Spring Boot web application. Following are the different tiers. We have presentation layer, we have service layer, and then we have data access layer. Let's talk about each one of them individually. So what is presentation layer? So presentation layer presents the data and the application features to the user. This is like the front end view, and this layer is the layer wherein all the controller classes exist. Okay, so what does controllers do? So controller accepts the request from the user, validates the inputs that the user has given, and passes it to the next layer, which is the service layer. So like I said, presentation layer does the job of presenting data and information to the user. Then we have the service layer, wherein the business logic resides in the application. Now, things such as evaluations, decision making, processing of data, all of this is done at this particular layer. This layer also does the job of interacting with both presentation and the data access layer. So this layer sits in between and does the job of communicating with both the layers, and they are frequently being called by presentation layer, and they will call the data access layer frequently. Now, what is data access layer? So data access layer is a layer where all the repository classes reside, and these repository classes are responsible for interacting with the databases, like performing the operations to read, retrieve, save data. And underlying databases can be any database, like it can be relational database or like NoSQL databases, but it is a job of data access layer to access the data and interact with the database lying under it. Okay, so this is how a typical Spring Boot architecture looks like. So these are the three different layers in which the application exists. Now let us take an example. Let's say we are building a library management system. So we will have a browser from where the user will be interacting with the application, since it's a web-based application. So this is our application, and user will be sending a request, and that request will be handled or received by the controller. Okay, so user interacts with the controller. Controller, it will take a look at the request and it will forward it to the service layer. Now, service layer classes interact with the repository classes, and repository in turn interact with the database. Now, service layer is the layer that will be responsible for all the logic that is related to our business, which is a business logic. So that will reside in the service layer. Controller and repository will do the job of interacting with the user and interacting with the database respectively. Then once the data has been fetched from the database by the repository layer, okay, what repository layer will do is it will pass the data to the service, and eventually the data will flow to controller and user will see it in his or her browser. So this is a flow in which a typical Spring Boot application works. The request comes through the controller from the user, then service, repository, and then it travels reverse back to the controller. Alright. So this is a typical architecture of a Spring Boot application. So that's about this class. I shall see you all soon. Thank you. So let us start talking about Spring Initializer and create a Spring Boot project. So what is Spring Initializer? So I'm here on this website, start.spring.io. Now, this is a website for Spring Initializer, which is a tool that enables you to generate or create a Spring Boot project. So if you're using free version of IntelliJ IDEA, which is the community version, that particular version does not have the ability to create a Spring Boot project. Okay, so you can create a Spring Boot project using IntelliJ if you're using the professional version of IntelliJ. But for free version, it does not have that ability. So for that, you need to make use of a free tool, which is openly available over here on start.spring.io. Now, this particular website asks few questions about your Spring Boot project. And when you hit generate, it will generate the complete project structure, which you can then import in your IntelliJ IDEA. Okay, and you can start coding over there. So this is a really handy website. You should bookmark this website because you will need this website every now and then if you're working consistently with Spring Boot, and provided you don't have the professional version of IntelliJ. So what I would say is you should head over to this website, Spring Initializer, which is here, start.spring.io. You need to select the project. So here it will ask you a few questions like what sort of project are you creating? So I'm creating a Maven project. So these are different build tools that exist. So I'll use Maven for proceeding with this project. Okay, you can use Gradle if you wish to, but I'll choose Maven. Now language, of course, will keep Java selected. And here it is asking you for the Spring Boot version. So here there are different versions of Spring Boot that are available. Okay, and you can choose any one of them. Now here you will see some versions that are labeled as snapshot over here. So you can see 3.2.0 snapshot. Okay. Now, using the snapshot version of Spring Boot is generally not recommended for production environments. And the reason is snapshot means pre-release versions, okay? Which means that these are still under development and they have been opened up for preview, and they might be incomplete, they might have bugs and other issues, okay? So they are intended for testing development purposes if you wish to try out some new versions of Spring Boot, okay? But snapshot version is generally not recommended. So I'll be selecting this version, which is a non-snapshot version. You have other version too, which is 3.0.8, but I'll choose the latest one. Now, another thing is when you see this lecture or this website, when you visit this, you might see a different version, like different numbers over here. Okay. Now that is perfectly fine. You can choose whichever is latest available because these versions keeps on changing as Spring Boot keeps on pushing new versions out there. Okay, so don't worry about the changing version numbers over here. Okay, so you can select the Spring Boot version starting with 3. Now 3 indicates you're using Spring Boot 3 version. Okay, so just make sure you're selecting the version that starts with 3. Okay, so once you've selected the version, here this particular tool will ask you for some project related information. Okay, now it's asking you for group. Now what is group? So group is nothing but the package name of the project. Okay, and this is usually the reverse of the domain name. So the default one here is com.example. So I'll say com.embarkx. Okay, so this is a website that I have. And then you have artifact. Now artifact is nothing but the name of the project. So the project name I can say as first spring here. Okay, you can enter any name that you wish to. Okay, so this artifact name and this name will also get updated over here. Okay, now description is the description of the project. So you can say first project for Spring Boot. Okay, and you can see the complete package name over here. Okay, so this package name is automatically generated based on the information that you have given over here. Okay, so this is about the project metadata. Now there are a couple of fields more that have been pending. So here you can see packaging. So applications can be packaged as jar file or war file. So I'll keep jar as selected. Okay, and here it's asking you which version of Java you wish to use. So I'll keep Java 17 version selected, which is the long-term support version or the LTS version that is available. If you have some other version of Java that you wish to use, you can change it over here. That is perfectly fine. Okay. So this is about the configuration over here, the project configuration. Now on the right hand side, you see the dependencies. All right. Now if you click on add, you will see some dependencies that exist. Okay. So you can see like Spring Boot DevTools, Lombok, Spring Boot Web. So if you're building a web application, you need to select the Spring Web, and what this will do is this will include everything like RESTful applications, like things needed for Spring MVC and an Apache Tomcat as well as the embedded container inside. So whatever is needed for you to build a web application, all of that will be included if you select this particular part. So you can scroll through and take a look at different dependencies that exist over here. So there are different categorizations, like you have web, Then here you have developer tools. Then here you can see template engines. This is Timeleaf. Okay, so if you are like writing some Java templates which are server side and you want to display HTML into the browser, so you can use Timeleaf. So the dependency will be included. You have security related aspects and so on. So you can scroll through, you can see JDBC. Okay, so if you select this and this, like everything related to the database will be configured. Okay, and you can take a look at the different kinds of databases that you can use over here. Okay, you can see MySQL driver, PostgreSQL, Oracle, and so on. Okay, you have NoSQL options as well, which is MongoDB, Redis, and so on. Okay, so there is a lot. You can just go through this list. Okay, so this is about the dependencies. So what we are going to do is we are going to search for web, since we are building the web application. Okay, now if you scroll up, this is what will be added. Okay, Spring Web here. Okay, and then you can click on Explore. So if you click on Explore, it will show you the project files that it will be creating for you. Okay, so you can take a look at the structure here. You can see pom.xml. You can see this is the entire structure. You can just take a look. Okay, so you can either copy, download, or I'll say close over here. Okay, and also one more thing I wanted to talk about is, so not this one, but this one over here. So this is a mode, like if you prefer a different mode. Okay, this is like, I don't know if it's useful for you, but you can, like, if you wish to have a dark mode, you can use this. All right. Then after doing this, you need to hit generate. So when you say generate, this entire project structure will get downloaded onto your system. So just hit generate and save this particular file on a particular location wherein you will be creating the Spring Boot project. All right. So that's about Spring Initializer for you. So just make sure you have downloaded the project structure over here from the Spring Initializer website and you have saved it to the desired location. So I have saved the file over here at this location of my choice. Now what I'm going to do is I am going to unzip it over here. So I'm going to say extract here. And this is going to extract and give me all the files within this particular zip file in this particular folder called First Spring. And this is what my project name was. Now we need to start using this project into IntelliJ. And for that, we need to import this project into IntelliJ. So what I need to do is I need to head over to IntelliJ. So when you open IntelliJ for the first time, you will see this welcome screen. And if you have created any projects earlier, you should see a list of recent projects over here. So you can say open over here. So I'll click on open. You can navigate to the location of your choice where you have this project saved. So I have this project saved over here. You can see First Spring. I'll select this. I'll say OK. Now it will ask you whether you trust this particular project, because what is going to happen is IntelliJ is going to run the source code that exists in this particular folder when importing. So it's asking you if you trust this particular project and whether it has been downloaded from the valid source. So yes, we trust this project. So I'm going to say trust projects in courses Spring Boot. So I'll trust all the projects that I have over here and I import in future. Okay. Alternatively, you can preview in safe mode if you don't trust it, but I'll say trust the project. And what is going to happen is it is going to open this particular window here. Okay. And it is going to load the entire project. So here I see a welcome screen where it's welcoming me to IntelliJ's new version 2023. Okay. It's giving me some tour over here. Okay. And here it also has some tutorial, like on the right side, some customizations. And here there is some processing that is happening. You can see. So it's updating this particular repository. So it is fetching, in short, all the dependencies. So if you click on this, it will say updating Maven dependencies. So I'll tell you what this means in a while, but what happened here is we had specified all the dependencies when we created the project. Like we specified web, Spring Web, and you can see the dependency here. So this was the dependency that we specified. Now to get this dependency onto your project, there has to be some download that needs to happen. And that is what the download that was happening here at the bottom. Now you have some customization options over here, like you can customize it to dark mode. Okay. So Windows is blocking some features over here. So I'll say allow. I trust IntelliJ. Okay, so you can change it to dark mode. Dark mode is brilliant. You can keep the system mode. Okay, you have an option to have a compact design or a clean one. You can choose whatever you want. I'll keep this to light mode. Okay, and I'll just say finish setup. Now you have some updates over here, okay, as to what's new in IntelliJ 2023. So you can go through this, okay. But let's explore the project structure over here, okay. So you can see the entire project structure on the left hand side over here, okay. Now you can see some folder, like you can see the src folder. So this is a folder where your source code resides, okay. So you have main, and under main you have the Java folder. So this is a folder where you can see like all your Java files coming up, okay. And you will have this folder here, this file here, which is the application file. This is by default created, okay. And you have this package name, which you had specified on the Spring Initializer website, okay. So this is the Java source code. This is where all your Java source code will reside. Now, if you expand resources, you will see static folder and templates folder and a properties folder. So resources folder is where all your HTML or like user facing code will reside. Okay. Then you have something called as test, and here is where all your test cases will come. Okay. So you can define test cases under this test folder. And then you have pom.xml. So you can see this pom.xml. This is one of the important files when it comes to Spring Boot. And within this file, it's an XML file. And within this file, all the dependencies of your Spring Boot project have been specified. So you can see all the configuration things over here. So you can see this is Spring Boot version that we chose on the Spring Initializer. Okay. This is the group ID, the artifact, the name of the project, the description, which version of Java we are using, and the dependency that we had selected. So this is a starter web. So when we said Spring Web on Spring Initializer website, this is the dependency that was added, and it's a starter project, as you can see. And what is starter project? So it has a lot of pre-built configuration for a specific purpose. So since we have specified the purpose as web, so everything that is needed for a web application is included in this dependency. Okay. Now you also have over here on the left hand side a folder, which is a huge folder, and the folder says external libraries. Now this is a folder which has all the libraries that are needed for the project. Okay. And if you scroll through, you can take a look at the different libraries that exist. Okay. So this is about the project structure. Now let us talk about this file over here, which is first Spring application. Okay, so this file has some source code in it. All right. And you can notice this annotation over here, which starts with the @ sign. Now, what does this annotation mean? Okay, so this annotation specifies that this particular application is a Spring Boot application. Okay. Now, if you go to this class which defines this annotation, so if I press and hold Control on Windows, or if you're on Mac, you can hold Command. And if you hover mouse on this, you'll see it being converted into link. And if you click on this, you will see that it's an interface. Okay. And this is a class. And you will also notice that this class has 3 more annotations. Okay. Which is a Spring Boot configuration. So this is one of the annotations. Then you have enable auto configuration, and then you have component scan. Okay. So Spring Boot configuration tells that this is a configuration file. Enable auto configuration tells that you need to enable auto configuration for this particular project, wherein the configuration should be done automatically. And then you have component scan, which allows you to scan for packages that exist. All right. Okay. So these are the three main annotations within Spring Boot application. And that is what we have specified outside over here. So I'll close all of these class files here. Okay. Now, if you go to pom.xml over here, okay, if you scroll up, you will see this Spring Boot starter parent. Now, this is one of the projects that is by default included in our application. And this particular project provides the default configuration for our application. Okay. And it inherits the dependency management from Spring Boot dependencies. All right. So that's all we need to know about this boilerplate code that has been generated by the Spring Initializer website. All right. So that's about this class. I shall see you all soon. Thank you. Let us talk about dependencies in Spring Boot. So dependencies refer to the external libraries or modules that your application would need to function properly. Okay. And Spring Boot makes use of Maven or Gradle build systems to manage the dependencies. So if you remember, when creating the project, we had selected Maven over here. Okay. So this project is created using the Maven build dependency, and we have a pom.xml file over here. Now this is a file that manages all the dependencies that are needed by our project. Now if you want to add more dependencies, you need to add the tags over here. So this is a tag dependencies which tells that all the dependencies are to be specified over here. This is one dependency and this is another one. Now, Spring Boot provides a wide range of starter dependencies, which are curated collection of commonly used and commonly needed by developers for a specific purposes. Now, these starter dependencies makes your life easier as a developer, and by including this, you can reduce a lot of boilerplate code. And you don't have to manage these individual dependencies manually. You need to make use of pom.xml file. For example, when you say, like, I need the Spring Boot starter web dependency, everything that is needed for a web application to function is included. Okay. Now, apart from this Spring specific dependency, you can also include like third-party dependencies that your application might need. And this could include some database connectors, some certain frameworks that you might need, or some libraries that you might need to do caching, or some other functionality that you might require. Okay. But by making use of this pom.xml file and specifying the dependencies here, you can easily save time and effort. Okay. So I'll show you, you can go to like maven.org. So since we are using Maven, I'll say search Maven. Okay. So you will see this link over here, search.maven.org. Now this is a link for Maven Central. And it says, if I zoom in, it says official search by maintainers of Maven Central repository. So you can discover different Java packages and you can even publish your own. So I'll go to this Maven Central over here. And you see the welcome screen over here. I'll say close. Okay. Now what you can do is you can search over here. So I'll say Spring Boot Dev Tools. So this is a simple search that I have performed and you get to see all the search results over here. Now you can see over here Spring Boot Dev Tools. Okay. And you can see the different information like the latest version, when the latest version is published, licenses, and all of that. You can click on this and you have this tag over here. Okay. So if you're using Apache Maven, you can like copy this and you can paste it in your project. Okay. You can even change this to Gradle, or if you're using any other build tool system, you can switch it to that. Okay. And you also have a Maven pom.xml file. You can see over here. This is an example file that you can take. But If you just need to add it to a Spring Boot project, you can just copy this and add it to pom.xml under the dependencies tag. Now you can go over here and choose the versions as well. You can take a look at the version. Okay. So if you need a specific version, you can go and check that out. So I will go to 3.0.0 and it will open up the page for that. So this is the version and you can see the version number over here, which is specified. Okay. So this is about the Maven search repository. Okay. Now, if I go back here, so here on the home page, you will see like some of the most popular packages that have been consumed by developers in last 90 days, some of the namespaces and so on. So you can like just play around with this if you wish to. Okay. And you can like just explore this a bit. Okay. Now you will also see some dependencies over here. So this is the official website of Spring Initializer and you're seeing some dependencies that you can add over here, and whatever you add over here, so I added Docker Compose, you will see the pom.xml being generated over here, like for that. Okay. Now, what is the difference in getting the dependency from Spring Initializer and Maven Central? So Spring Initializer provides a curated list of commonly used Spring Boot dependencies that cover a wide range of use cases. Okay. However, it may not have every single dependency out there that exists within the Spring ecosystem. So there will be scenarios wherein you might want something and that does not exist on Spring Initializer. Okay. So you could go for Maven Central then, or you can visit the official website of the provider for that as to how you can include it. Okay. But there will be several reasons as to why that dependency is not included on Spring Initializer. Okay. And some of the reasons that I could think of is, the number one is it's a custom or a lesser known dependency. Okay. So Spring Initializer focuses on what is popular and what is commonly being used in the Spring community. So if a dependency is relatively new, niche, or it's less commonly used, then it may not be included over here in this particular list. Okay. Also, start.spring.io, like the Spring Initializer website, includes the latest stable versions of the dependency. Okay. So if a specific version of the dependency is not considered stable, then it may not be included in this list. Okay. And also, this particular website is maintained by the Spring team and the community. Okay. So they gather a lot of feedback from the community, and based on the community feedback, they make sure the dependencies are available. So these are some of the factors as to why you might not find all the dependencies over here. But if you don't find anything over here, nothing to worry. You can like head over to Maven Central and search for whatever you are looking for. Or like I said, you can go to the provider's website. All right. So that's about dependencies in Spring Boot. So now is the time to start creating our first API. So we'll create a very basic API and we'll understand how things work with Spring Boot. And this will be a RESTful API endpoint. All right. And for that, we are going to need a controller. So I'm going to go to the project structure. I'm going to scroll up, collapse everything. And here I'll go and I'll say new. I'll say new Java class and I'll call this as hello controller. And I'll press enter. Now, if you have Git configured, you will see this pop-up. And if you don't have, you might not see this pop-up. So I have Git configured on my local machine, and that is why it's asking me to add this file to Git. So I'll say don't ask again and add. Okay. Now here in this controller file, I'll start writing some code. Okay. And I've called it hello controller because we are going to just create a simple hello world API. All right. I'm going to first say @REST controller. So you can see this auto suggest, and this is the annotation, which means that we are ready to use Spring MVC to handle web requests. All right. So we need to specify this annotation if you're building a REST API. And now we are going to create a GET request. So I'm going to say public. I'm going to define a method. I'm going to say string hello. So it's a very simple API, and I'm going to return hello world. You can return anything you wish to, but I'm returning a simple string. And now here we need to, so we have this method here. Now how do we map this to the URL? So we can map this using annotations. So we have defined this as a controller using annotation. We will use another annotation, and you will say @ and I'll say get, since this is a get mapping. So I'll say get mapping. Okay. And as a parameter, I'll specify hello, like so. Okay. So what we have done is, if any request comes on our domain with /hello, so domain name /hello, we will be invoking this method, or Spring Boot would be invoking this particular method and executing the logic that we have written inside. All right. Now let's take a look at REST controller. So REST controller annotation is a specialized version of controller annotation. So you have this annotation as well, controller, okay, which you can see, right? But I'll delete this, and I'll delete the import as well. We don't need the import. But REST controller annotation is a specialized version of controller, and it combines two annotations, controller and response body. And if you wish to see, you can hover on this and press Control or Command. So if you're on Windows, you will press Control. On Mac, you will press Command. And I'll go into this annotation, and you will see you have controller and response body annotation here. So there are other annotations as well, but these are two main ones. Okay. And this indicates that this class is responsible for handling HTTP request and return the response in the form of a RESTful representation. Okay. So that is what this specifies. And we have specified this annotation, which means that we have informed Spring Boot that this is what we are doing over here. And then we have this get mapping annotation with which we defined a get mapping. All right. Now what I will do is I will run this particular application. So I'll go to first spring application.java, and I'll say run over here. So this will run the Spring Boot application. Okay. You can see some processing happening over here. Okay. And you will see this message here. Tomcat started on port 8080. All right. So on your local machine, this application has been deployed on the Tomcat web server, which is now available on port 8080. So what you need to do is we will switch over to our web browser. So here in the web browser, I'll say localhost 8080. So of course, we'll get an error over here. So we get an error, white label error page, and this is a default error page that Spring Boot provides. And it says that there is no mapping defined for this particular URL, which is correct. So we have defined the mapping for /hello. So we need to access that. And you can see over here, we have the first Spring Boot application working up and running in our browser. All right. So what we did, we literally just wrote some small piece of code, a very basic method, and we have the output in the browser. All right. So that's how you can create a Hello World API using Spring Boot. Let us understand how our API worked. So when we executed our application, okay, we have kept our application running so far. So if you want to keep accessing your application from the browser, you need to keep the application running and don't stop the server from here. So this is how you can stop the server, but don't stop if you wish to keep accessing the application. Now, if you scroll up here on the console, the number one thing, when you start the application, you will see this Spring banner that appears printed on the screen. Okay, and this is the first thing that you would notice. And this is a Spring ASCII art banner. That is what it's called. And you will also see the Spring Boot version being printed. Now, after you scroll down, you will see that our application is starting over here, and it indicates that the application is being started. Now, if you scroll back, you will see the environmental variables are being set over here. Okay. So here we don't have any active profile, okay, and it's using the default profile over here. That is what it says. Now what I mean by profile is you can set variables like environmental variables in application.properties file. You can define some properties over here. Okay, so we have not defined anything and we have not done anything over there. So it's picking up the default one. So that is a default property file that we have, and that is being picked up, and that's empty. All right, so environmental variables have been set. Now after environmental variables have been set, Tomcat server is being started. So you can see over here, Tomcat is initialized with port 8080. Okay. Now if you scroll down further after the initialization of Tomcat, you will see like servlet engine and everything is being initialized. Okay. And then the Tomcat was started on port 8080. All right. So this indicates that our application was ready to access. Okay. And then we went over to the browser and typed in the URL to access the API that we have created. Now what happened when you tried to access the API? So when you typed in this URL over here in the browser, like localhost 8080/hello, the request was prepared, and this is a GET request that is being prepared from the web browser, and it was being sent to this particular port number on this particular URL. And you have the Tomcat listening over there. Okay, you have your web application listening over there. And once the request was sent, the request was accessed by the controller over here. So if you come over here, you can see that we had defined this controller, and this is what intercepted the request, and it processed and executed the method over here and returned the response. So this was the entire controller action that happened over here. So if I disable this, if I hide this, so you can see this controller came into picture and it served the request that was being fired right from the browser. Okay, and the response was sent. Now when sending the response, this particular string was packaged into a HTTP response and it was shown onto the browser. All right. So this is what the entire process that happened. Okay. Now there is a significant amount of to and fro that happened, and it happened within a fraction of seconds. Okay. Now imagine if you have more layers defined, like if you have, this is a controller. Let's say if you have service and data access layer defined. So this all happens within a second. All right. So that's about how our application was executed. Let's talk a bit about how Spring Boot auto configuration works. So when you ran the Spring Boot application, you saw that there was a Tomcat server automatically set up. So this is one of the magics of auto configuration, and this magic is being done by Spring Boot auto configuration feature. So this was automatically configured, set up for you, and your application was deployed without you doing anything. We just created the project and imported it, and we wrote a simple controller function. Okay. The next thing I want to talk about is this dispatcher servlet that you see over here. So it said initializing servlet, dispatcher servlet. So dispatcher servlet is at the heart of any Spring MVC application, and it routes incoming requests to the appropriate controller methods. Okay. Now Spring Boot takes care of configuring this dispatcher servlet for you. It auto configures this servlet and it saves the effort of setting it up yourself. Okay. The next thing is the REST controller annotation. So REST controller annotation at the class level tells Spring Boot that this particular class is a controller, and it knows that it is a controller and it should handle the HTTP request. Therefore, it creates a bean for this. Okay. So a bean is nothing but an object that is being managed by Spring. Okay. So bean is created for this particular class in the application context, and it is being mapped to the controller. Okay. So this is all handled by Spring Boot. You just have to specify this annotation and tell Spring Boot that, hey, I will be defining all the endpoints in this particular file. Then we defined the get mapping annotation. So here in the controller class, Spring Boot auto configuration detects that get mapping annotation is specified for this particular URL, and it automatically executes or maps this particular method whenever you call this particular URL. And that is what we saw in action. Okay. So another thing that Spring Boot does for us is default error mapping. So if you access any endpoint other than what you have specified, so like we tried to access the root URL here. So you got this error page. Now this is by default generated error page, and this is pre-configured for you. Okay. It's a simple page. Now if you want to have a custom page, you can definitely modify this. Okay. But this is also one of the magic of Spring Boot auto configuration. Alright. So this is about Spring Boot auto configuration and how Spring Boot makes your life easy. Let us start talking about application properties. So in Spring Boot project, we saw this file application.properties which exists under resources folder. Okay. Now this properties file is used to do configuration in Spring Boot. So you get a pre-configured application with Spring Boot, which you can then customize by using this particular file and specifying the key value pairs. Now, what are the key value pairs that you can specify over here? So for that, you will head over to the browser and you can search for application properties Spring Boot. So I can say application properties Spring Boot. Now you will see this first link over here, which is the official link that I have opened. And this depicts the common application properties that you can make use of. Okay. Now you can see this is supposed to be specified in application properties or application.yaml. So .properties is one format, and then there is another format called YAML format. So if you wish to use YAML format, you are free to use, but we will stick to .properties. So here are the properties that you can take a look at, and this is the categorization of the properties on the left hand side. Okay, so now you can scroll down, and if you scroll down a bit, if I say Control F, I'll say server dot. So if I select server properties, you can see this particular property here, server dot port. So this is a property that is used to specify the server port. So when you executed the Spring Boot application, it was by default accessible on 8080 port. Now, for some reasons, if you wish to customize the port, you can do that by specifying this particular property. Now let me show this to you. So I'll head over to our ID and I'll say server dot port is equal to 9090. Okay, and I'll hit save, and now let me rerun the application. So I'll stop and rerun. Now if you check the console logs over here, you can see it's running on 9090. Okay, and if you go to the browser on 8080, if you refresh, you won't see anything. So it's like site cannot be reached. And if you enter 9090, like over here, you will see this error appear over here. Okay, and you can go to hello and you will see the endpoint working perfectly fine. So this way you can customize the defaults that you have got using this particular application.properties. Okay, so you can go over here and you can specify this. So I have some properties pre-written over here. So these are some of the properties that enable you to specify or configure a data source connection or a database connection. So you can say, so this is an example for configuring a database connection for MySQL database. Okay, and suppose you have a Spring Data JPA application which interacts with the database. So you can say the database URL is this, username is this, password is this, and you're specifying DDL auto update. Now what this means is you are telling Spring Boot to connect to this database. Okay, and this last property is telling Spring Boot to automatically create or update the database schema as needed. Okay, So with update, if there are any changes, it will simply update and create. Now, one important thing to note over here is that properties defined in the application.properties file can also be overridden by command line arguments. Okay. So you can run your application by command line, Spring Boot application. So since we are using an ID, we are not doing that. But you can specify the argument as server.port is equal to 7070 while running. And this will make sure on command line the 9090 is overridden and it runs on 7070 instead, even though you have specified 9090 in your application.properties. So this way you can make use of application.properties file, okay, to like configure some pre-existing configuration that has been given to you by default by Spring Boot. Okay. So this is about application.properties. Let us talk about how you can create a post request. So the first thing, I will remove this server.port property and I'll let my application run on the default server. Okay. Then I'll switch over to hello controller. So this is where we will be defining the post request. So we have a get request. Now post request is another type of request with which you can send some more information. Okay. So we have an annotation @get mapping to define a get mapping. Now what will it be for post? It will be post mapping, like so. And we will keep the URL same. So I'll say hello, like so. Now here I'll define the method. I'll say public, I'll say string, and I'll say hello post. So this is the method that will handle the post request. Okay. And here I'll return something. So I'll say hello. And let us return the name over here. Okay. And I'll add an exclamation at the end, like so. Now we are returning the name of the user or whatever is passed with this post request. Now where does this name come from? So we are getting an error right now that name is not defined. So we need to give this name as an input to this particular method. And this name should be accepted from this particular post request. So for that, I'm going to add an annotation over here. I'm going to say request body. So from the request body, give me string name here, like so. Okay. So in get, we did not have any parameters because get is just a method, like get is just a request call. Okay. But in post, you can send some data along with the request. Okay. So what we are saying is we are saying request body, and this request body annotation is used to indicate the request body that should be bound to the method parameter name. Okay. So with this, we are done defining the post mapping over here. Okay. Now what we can do is I'll rerun the application. But the question is, how do we access this using the browser? So we cannot access or we cannot execute a post request from the browser. And for that, we need a special tool, and a tool like POSTMAN could help us do a post request to our application. All right. So far we have created the post request and we have returned the response. Now it's time that we should see it in action. So after defining the post mapping, we need to now figure out a way to execute this. So it's not possible to execute this from the browser like we did for get mapping, because we need to pass some additional information with the request. And there are some special tools that enable you to execute post queries. So for that, we are going to head over to the browser and I'm going to search for POSTMAN. Now, POSTMAN is a tool that enables you to work with APIs. So I'll go to POSTMAN API platform and you can read and learn more about this particular tool. Okay. Or what I'm going to do is I am going to straight away download Postman. Okay, so I don't find the download link over here. Okay, so you have to go to product and you can say get started for free, and you will be taken to this page where you can download Postman. Now it will automatically detect your OS, and since I'm on Windows, it's telling me to download for Windows 64-bit, or you can even try it on web if you don't want to install it onto your system. And this is what it will look like, the interface. Okay. So what I'm going to do is I'm just going to download this particular tool for my Windows machine. So as you can see, it's being downloaded. Okay. And it's been done. Now what I can do is I'll double click on this and I'll get this installed onto my system. Okay, so I believe we downloaded the portable version. Okay, so it didn't install, but it just directly launched, and I'm going to add it to my taskbar as favorites. Okay, so you can hit download button over here. Okay, and download the respective version for your operating system and get it installed. The installation steps are very, very easy. Like it's just like any other software with no complexity. Once this is installed, so I already have this installed onto my system. So once you launch this for the first time, you will see an interface like this. Okay. Now you can see on the left hand side, you have this pane which talks about history. And this gives you the history of all the requests that you have executed. On the right hand side, you have this pane to execute a request. And along with the request, you can pass in additional parameters, authorization information, headers, body, and so on. So a lot of information you can send along with requests. And this particular tool is just for working with the APIs. So what I'm going to do is I'm going to head over to 8080. I'll copy this URL and we need to write a post query. So I'll paste this URL here. I have get selected over here and I'll say send. So you can even run the get request. As you can see the output. I'll just zoom in a bit. So the output is hello world, and this is the exact output that you were getting from the browser. Switch this to post. Okay. And now here in body, you need to add some body. So I'll select body. Okay. The reason I'm selecting body is we need to send the request body along with the request. So I need to add a body. So I'll go to body. Under none, I'll say raw. And I can specify anything over here. So I can specify hello Spring Boot. Like so. And I'll keep text selected and I'll say send. And you will see hello Spring Boot. And you can see 200 OK over here. So after execution, the default status code that you get after successful response is 200 OK. Okay. And you can see the time 16 milliseconds. And this is the data. Okay. So here you can see the history appearing as well. Okay. So even if you fire get query, so if I fire a get query, you can see the status code as 200. Okay. So the status code for both was 200. Okay. All right. And you can see the response generated as well. So you can make use of Postman, okay, to play around with different API queries or different API requests, not queries. All right. And Postman is pretty handy and it is being used widely. All right. So that's about how you can work with post requests with Postman. Thank you.